Hi, I'm Adolph Oliver, and this is a video about how to work with polynomials that have more than one variable. And besides having more than one variable, it can have variables of different powers as well. Now, what this means is you have to be more careful about matching like terms, because you need to remember that like terms have the same variables to the same power. Let's look at this beginning example here, a little simple of adding two binomials together. Notice the first term inside the parents here is x squared y. Well, the square goes with the x. Remember, if you don't see an exponent with the y, we assume it to be 1. Well, notice in the second polynomial over here, there is a matching x squared y. So these two guys are like terms. The variables and their powers match exactly. Now, there's also somebody else here. Inside the first binomial here, we have an x squared. Okay, well, that's just an x that's being squared. Notice we happen to have the same thing in the end of the second one. So these guys are like terms. Now, we don't see a sign in front of this first set of parents, so we assume it to be plus. The sign in front of the second is plus, so these guys are being added, and pluses, of course, when you distribute them in, don't cause any changes. So in this particular problem, there's no need to rewrite everything. All we simply do is say, okay, let's combine the like terms. This is officially a plus 3x squared y, and this is a minus 1x squared y. So plus 3 minus 1 gives me 2 of them, and remember the variable here is x squared y, so there it is. So as usual, we simply combine the coefficients. Remember, of course, you can always put a 1 in front if there's no number. So 3 minus 1 gives me 2, and the like terms, x squared y. Now, the x squareds, plain x squareds here, no y with them, so, but they can match because x squared here and x squared here exactly match. I've got, of course, minus 1 of them right here, and positive 4 here, so positive wins by 3, so plus 3, and of course the like term here is the x squared. Okay, well, there's nothing new in this topic here, except that now you have to be more careful about how you match up like terms because you have additional variables. But once you get used to that, it's not a difficult thing. Okay, let's look at some more examples here. Here's one where we've got, let's see, we're adding and subtracting. So these are 3 polynomials, a binomial here, a trinomial in the middle, and a binomial on the end. Once again, we don't see a sign on the guy in front, so we assume it to be plus. But notice that we do have a minus in front of the last guy here. So if there's any one of them that has a minus, and we've got one of those, you should then rewrite everything. Now remember, of course, when you distribute the plus in, it doesn't change anything. So this minus 4 remains minus 4, and the minus 2x cubed remains that. Now, likewise, when we distribute the plus into the middle polynomial, it's not going to change anybody. So this plus 3x cubed remains that way. Okay, then we have plus 6xy to the 4th. It remains the way it is. And then we have minus 6y squared. Same thing there. It doesn't change. But now, the guys on the end here, the minus being distributed in, everybody changes. Minus 13 becomes positive 13. Minus, or should say positive xy to the 4th becomes minus xy to the fourth. Now, any of the ones that you're changing, double check them. Minus went to plus, so I changed. Plus went to minus, so I changed. Okay, now, let's take a look at where we have like terms here. I see x cubes all by themselves, so here's one here and here's one here. Then I see xy to the fourth. Well, here's another xy to the fourth. So I'll be combining these guys because they're the same. Okay. Here's a y squared. Well, there's no other y squared, so I'll just write him down the way he is. And of course, when I finish up, I'll combine the plain numbers. So let's see what we end up getting with this. If I combine the x cubes first, I've got minus 2 plus 3, so I end up with positive 1x cubed, which I can just write as x cubed. You could put the plus or the 1 in front if you wanted. Now, I like to cross out the guys once I've combined them, so I don't bother looking at them again. Let's do the xy to the fourth next. We got plus 6 and minus 1. Well, that's going to give me plus 5. And again, the variable like term is xy to the fourth. So here it is. So plus 6 and minus 1, there that goes. Now, there's only one variable term left, the negative 6y squared. Nobody to combine it with, so I just write it down like it is. Okay, there it goes. And then the last thing, minus 4 and plus 13. Well, okay, those are plain numbers. Positive's going to win by, I think, 9. So plus 9. So there we go. Here it is, all the like terms combined, a lot simpler than the original guy up here on top. Okay, the next one we're dealing with here, we've got a multiplication. But one of these guys is a trinomial, so I can't use regular FOIL. So I either have to use vertical multiplication or the box method. I'll go ahead and do the box here. So let's make ourselves a box, and I make it longer along the top because I've got more terms in the top one I'm going to put in. Let's write down the top guy. Plus 3a squared plus 2ab plus 2b squared. And then along the front, the binomial here, 2a, officially a plus, and then minus 8b. Now remember what you do. The guys in front each have to have their own rows, so I have to split the box in half. The plus 2a will be in the top row, the minus 8b in the bottom. Likewise, the guys in the top have to have their own columns. So here they go. Okay, now our job is to fill up all those boxes and then combine them together to get the final answer. Okay, well remember, this is now like distributive property. We take this plus 2a and multiply each of the guys up on top. So plus 2 times plus 3 is plus 6. A times a squared gives me a cubed. Now, moving over to the middle guy. Plus 2 times plus 2 is plus 4. And a times ab, well, we're going to have two a's, so it'll be a squared and then b. Okay, the guy in the end, plus 2 times plus 2 again, so plus 4. And I've got a times b squared, ab squared. Okay, now down to the guy on the bottom row. Negative 8 plus 3. Negative 8 times plus 3 is going to be negative 24. And I've got an a squared and a b, so okay, there's the a squared and there's the b. Now, the middle. Negative 8 times plus 2 is negative 16. Okay, I've got b times AB. Well, that's a single A, and I'm going to end up with two B's, so B squared. Okay, the guy in the end, minus 8 times plus 2, again, negative 16. B times B squared, well, that gives me a total of 3B, so B cubed. Okay, now remember, since we wrote these in descending order here, and alphabetical order here, A's first, B's second, then we can turn around and put the problem together, starting from top left to bottom right. But I always like to circle the guys that are like terms. Notice these are the A squared B guys, and this is the A B squared guys. So, okay, let's put it together. We've got 6A cubed. Here it goes, 6A cubed. Okay, and then let's see, how many total A squareds B? Minus 24 plus 4. Looks like it's going to be minus 20, and that's A squared B. Okay, move over to the next. I got negative 16AB squared and positive 4. Well, let's see, negative 12, I think, is what we get when we combine those. So minus 12AB squared. Okay, and then, of course, the last thing to write down here is just the guy in the bottom right corner, negative 16B cubed. Well, once again, got to be more careful here because you got more variables and different powers going on. But if you look at it very carefully, follow it along, you can get it to work out. Now, some shortcut guys here with more than one variable. Notice we're multiplying two binomials here, and normally we just, okay, go ahead and hit with FOIL. But notice that these two binomials are exactly the same, except the signs are different. One is plus and one is minus. That makes this one of the difference of two squares shortcuts. And the thing we remember about that is we don't have to bother doing the O and the I, the two rainbows, because they'll knock each other out. All we have to do is multiply together the two firsts, 6x times 6x, 36x squared, and then multiply together the two last. Plus 3 times minus 3 is negative 9. Y times y is y squared. So, okay, there it is again, our difference of two squares. And, of course, we can also bump into one of these perfect square trinomials and use our shortcut on that. Notice we got more than one variable here, y squared here, z squared here, but it's a binomial squared. So that being the case, we can use our shortcut. Remember, what you do is you square the first guy. 2y squared times 2y squared, well, 2 times 2 is 4. Y squared times y squared gives me a total of 4y's, so y to the fourth. Take the last guy, square him. Okay, well, negative 3 times negative 3 is positive 9, and then z squared times z squared gives me a total of 4z's, so z to the fourth. Now, don't forget the center term. We make the one rainbow that we can here. Multiply together the guys on the end of the rainbow. 2 times negative 3 is negative 6. And then we have y squared times z squared. Okay, y squared times z squared. Now, the only thing you have to remember is when you write this down, don't forget that you have to double it. And again, you don't change the sign, you don't change the variables, you just double a plain number. So doubling 6 gives me 12, so negative 12 y squared z squared. Well, okay, we've given you a range of examples here of working with polynomials that have more than a single variable. And of course, what you have to be is just a lot more careful in making sure that everything matches.